Okay. Hi, good evening, everyone. I hope all of you enjoyed your weekend. So, along with the same mood, let's go for today's project presentation. My name is Saivarajan. Myself and my team A are here to present over the project of association rule and recommendation engine for high utility item set. Before go to the introduction of my team member, I would like to talk about little about the topic of project. So, as you know, in this modern digital era, everyone day-to-day life, everyone we are prepared to go for e-commerce site to get our favorite product rather than go to the shop. For example, I can say Amazon, Flipkart, etc. and all OTT platform like Netflix, Amazon Prime, etc. So we access so many products and services. This will make our easier life easier too. So before knowing the data science, we wonder whatever we search in the product in the Google, it will come in front of us while using the mobile phone. So due to this development, there are many companies are in the race to retain their loyal customers and increase their sales and profit. So they are keen to provide the more choice according to the taste of the customer. So all the companies following different approach to achieve the benchmark in the market. So ultimately, the recommendation engine and the association rules will be the key for playing a vital role behind the screen. So in our presentation, we will come to know what is the objective and constraint and what algorithm and tool environment we used in this project. So before proceed further, I am so glad to express my sincere thanks to Data Director Mr. Sharat Manikonda. And also I would like to thank for mentor Mr. Raju to give the great full support to complete the project successfully. So now I would like to introduce my team members to you. Here you can see our team member who are put their great effort to successfully complete the project. Thomas Amul, Swarna, Manikandan, Abhijit, Ayvarajan, Surya Prasad, Rubendra, Vaishali, Babin Babu, Vignesh, Barka, Brinjal, Ravi Kumar, Karthik, and Ashu. So now I would like to take you through the basic introduction of the project, like what is the purpose of project and what benefit by doing this project and what we are trying to achieve those through this project. So here our objective is to ensure the product recommendation system to help the customers to get better product recommendation, maximize of business relationship between the customer and retail, ultimately maximize the business profit. Of course, every company is looking for this, and minimize the time taken to recommend the product. So according to this project, we don't face much major constraint in the project. But anyway, in our perspective, we have a 2 point because we feel it is a constraint. So implementing fuzzy without simple full is little complicated. And it's not like other model, we can't pass the string value into the fuzzy algorithm while implementing the simple full. So this is the 2 point. We feel this is a constraint for our project. Next. Crisp ML methodology. So in every data science project, the crisp ML methodology, it's a best practice in any data science project. It's clearly describe the all cycle of the model. And basically every step of project comes under only those tips. It cover under these tips. So now I'm going to tell only overview of the crisp DLM and elaborately we'll see in the upcoming slide by which is explained by our team members. So first step, business and data understanding. So in this step, it will helps to understand what you want to accomplish from the business perspective. So it is well described in our objective and constraint also, and it helps to know the maximization and minimization of organization. So when come to the second step, data engineering. Yes, of course, after we collected the data in data collection and data featuring and data cleansing, so everything will come under this one. So we follow the same method to just clean the all the to clean the data from the raw data which we extracted from the website. The third stage is model building. See, this model building is a very critical, crucial part in our project. So here our algorithm we are set and we are implementing to the project and we build the model here. Then it goes to the next slide, model testing and evaluation. So whatever we implemented in algorithm, here we are just checking our accuracy of the algorithms model. So after it goes to the deployment part. So deployment part is the final part where we implementing what are the things we learned, got from the model. So we deployed the part, and finally the monitoring and maintenance goes to this. So our project will comes every aspect of this piece. It comes, we covered all the things in upcoming slide elaborately. Can you go for next? Yes, technical stack. Of course, Python is the basic things. It's open source for our project. Without this, we just not able to complete the project. So in this Python, we have used two environmental, Spider and Jupyter. Libraries, yes, we used NumPy. As you know, all mathematical things we can do it on the NumPy. And Pandas for all data manipulation. And all important things are happening in this Pandas. And Erasa, Simpleful is another libraries we used on MATLAB for better data visualization. API. So we have two kind of API here. Either web-based, we used Streamline, and cloud-based, we used Character. So here I would like to conclude from my end. Now my team member will talk, taking you through the project. Swarna will take the view. Swarna, send out to you. Thank you. Thank you everyone for giving great opportunity for me to present this.
Thank you, Avirajan. Good evening, everyone. I'm Swarna. Let's see how to prepare environment for this project. To create environment, we use Python version 3.8. In this, we create a new Anaconda environment. After installing the Anaconda software, we need to launch IDE platforms like Spider and Jupyter. Install Pandas for pre-processing the data. Pandas is a Python package, and also it is well suited for many different kinds of data. We have installed simple library for fuzzy logic, and also we have imported NumPy and matplotlib libraries. Here for visualization, we use matplotlib library. To run the fuzzy logic system requirements are 8 GB RAM, AP processor, and Windows 10. These are specifications to run the fuzzy logic. Now I'm going to explain about project architecture. Here you can see the fuzzy logic based recommendation. First, we need to understand what is project objective. Here, our model is to recommend a high utility item based on the customer search. We have taken a primary data. In our data, we have 1,08,033 rows and 6 columns. Like columns are customer name, fruits, vegetables, milk, rice, and price, like that. After understanding the data, we have done data pre-processing. To build a model, we need to give schema data. For that, we have done some imputations, like we have dropped some unwanted quality details, and we have removed all duplicates, like that. Next, in unsupervised learning, we have used fuzzy logic based recommendation. Here we have two variables like linguistic and Sigeno. In fuzzy application, if we choose any type of item like fruits, veg, rice, and milk, the recommendation will work. After recommendation, we have deployed our model. For web-based, we have used Streamlit library. For cloud-based, we have done with Heroku. This is all about project architecture. Thank you, everyone. Over to Abhijit.
Yeah, thanks, Swarna. My name is Abhijit. Good evening to all. Data collection. It is the process of gathering and analyzing accurate information on variable of interest. We collected data from Kaggle site. Then we give randomly rating to each customer. After rating, we calculated customer purchasing behavior and give the individual rating to each item. Next. After collecting data, we understand the data. We extracted that data online e-commerce domain. In our data set, there is it is categorical data, 4 types of category like milk, vegetables, rice, rice, categories there. In that one, the rows contains 1,08,033 and 6 columns in that data set. In order fruit, there are 25 unique atoms in that data sets. In vegetable, there are 13 unique atoms in that data set. And in milk, there are 3 unique atoms. And rice, there are 70 unique atoms in that data sets. Next. In data preparation, this is the steps for preparing that data. We first cleanse and validate that data. After that, we removing outliers by using the box plot techniques. After that, we filling the missing values in that data set. After we confirming data to a standardized pattern. After we masking the private or sensitive data entries. After that, we remove all duplicates, which is repetitive value present in the data sets. After that, we generating some random points into the unique atoms and calculated points for each customer based on the atoms. Next, please. This is the visualization of order fruits customer purchased by the fruits, and we visualize that data. This is the highest, 12 is the highest bar counts of order fruits purchased by the customer, and 2 is the lowest bar ordered by the customers. Next. Same for vegetables. This is the different types of the vegetables purchased by the customers, and we visualize that data. Next. Same for milk. Customer just order the milk, and we visualize that different category of milk through visualization. Next, please. Yeah, this is the different categories of rice purchased by the customer, and we visualize that rice item sets. You can see that one. And next slide, I will present my friend Surya. Thank you all.
Yeah, thank you, Abhijit. So good evening all. Myself, Surya. Let's see about a model building part. In the model building, we're using a simple full library. In the simple full library, we're having a 2 variables, a linguistic variable and Sugino variable. In linguistic is an input and Sugino variable is making an output. In that, we are having 2 variables and fuzzy rules is there. We're giving an input from the data set and fuzzy system is working on that and giving the result. This is a flowchart of that. Let's see what is a linguistic variable and Sugino variable. In linguistic variable, it is a whose value is in natural language, it will process easily. For example, your data set is speed means it will take the value as slow, fast, very fast, and so on. Coming to our data set, we are having a rating column. It is a high or low. Like customers giving high means it is high, it is low means it is low. With a rating, we are telling that. In Sugino is a smoothly interpolating the linguistic variable input. That means low and high. It is giving the non-linear system into a easiest spot to give the output. The model flow we running in the model building, define a fuzzy set. After a linguistic variable is an input variable and making appropriate rules, and Sugino inference output and making a recommendation to the customers who purchasing the varieties of products. Let's see how the fuzzy code is working. This is the theoretical part of the simple full model working. In our data set, we are having 4 variables, that is milk, fruit, rice, and vegetables. It is the 4 variables we are having. Let's see, it is a theoretical part. Let's see in the code how we deploy in that one. Model is done. See that we import in the simple full model. After that, we are having 4 varieties, that is fruit system, vegetable system, and milk system, and rice system. These are the 4 categories that shop is having. That is making into a fuzzy system, the 4 categories. After that, for 4 categories is done, we want to give the linguistic variable. What is the input for that each categories? That is the input is in linguistic variable, they are having 2 points, that is P1 and P2, with the term high and low. P1 is having a high and P2 is having a low. That P1 and P2 is telling about how the high and low is interpreting in the code. In the code, high and low is telling that in our data set, for example, I am taking the fruits column. In fruits column, from previous purchase behavior, some rating is there. Let's see, take the full category into that median value. That is the center is 20. That C is equal to 20 is implicating the median value of the rating. That is the center value means that universal disclosure is there. That is 0 to 50. And double is the center. that makes the 0 to 50. In middle of that is 20. That is below the 20 it is low, above the 20 it is high. It is a P1 and P2 is telling that P1 and P2 is saved in a linguistic variable. Input is given to linguistic variable that each fruits, vegetable, milk and rice, the similar we want to do, and save it in a consolidated fruits means fruits, and vegetable means vegetable, rice means rice, milk and means milk. Let's see what is the what we done in that linguistic variable. So let's see the graph of that each one. The graph is showing the vegetable score. I tell you about that mean is the 20 means. You see that a blue and red line is crossing in a 20 line. That making is the middle of that one. This is below the 20 means low, rating is low. Above the 20 is they buy only high products. They buy many products in the vegetable. Like that. After that, we're making linguistic variable. I show the figure of that, produce the figure for each fuzzy system of the fruit vegetable system. We want to make the rules. Once they're purchasing this, they will purchase this. Like that, we want to make the rule. For the rules, we want to give the crisp output. Like high chance of fruit is 100. That is the highest value. Low chance of fruit is the lowest value 10. Like that, we want to make it for all the vegetables, fruit, milk, and rice, and saving it to a consolidated fruit system, vegetable system, milk system, and rice system. After that, we want to make the rules for that one. For rules, I am taking example for fruits. If customer is buying many fruits and giving a high points in the fruits, there's a no chance of extra they will buy. So it's a low chance of fruits. Then purchase a low chance. If purchasing very 2 to 3 products means is a low fruit point is low. The purchase high chance of fruit is there. It's similar to that milk points and milk and rice and vegetables. It is the rules based, and all the rules are saving into a consolidate fruit system and vegetable system, rice system, milk system. I tell you that rule 1 and rule 2 is fruit system, like similar to all the two. But all are done. But output is how it is coming to that fuzzy system that given A, B, C, D. That defining fuzzy with A, B, C, D is telling A is a fruit point, B is a vegetable point, C is a rice point, D is a milk point. In A, that customer, example, one customer is coming and purchasing a fruit means that fruit means some the 3 to 4 category they buy. 2 varieties buy means they will give us some points. Think that 50 is a middle value. They given the four categories they buy, that is more than a 50 means it is 55. Think about it is a 55. That is A. But B, C, D, the vegetable, rice, and milk is not buy means A is equal to 65. Now it is saving inside a fruit point and it is going into a consolidated fruit system. In fruit system, what they purchasing vegetable means vegetable system, or is saved in a each category. After that, I tell you about that how that output is coming with the use of smooth interpolation, Sugino inference. F is equal to F is the fruit. F is equal to Fs is saved. 65 point is saved. That is Sugino inference. In bracket, there's a purchase is there. What is indicating? See that in the rules, the purchase is milk. Example, milk point. Take the in rules. Take the milk point. Milk point is low. That means that the customer given the rating is 65. It is not low. I tell you the median value is 50. Mean it is high. Milk point is high. So the purchase is telling low chance of milk. We tell like it is low chance mean they all are bite. There is no need to give some of the products. So we can give there is 3 categories only in the milk. We can give the last 2 categories. Why I am taking the last? How we taking from the previous customer behavior? We making it a descending value from high to low. That they purchase some of the high value means we can give the last 2 values of the milk. Like the similar to the rice, similar to the vegetable. They purchase 4 of them means A, B, C, D means all the variety means we can give 4 varieties of that one. Easily he can interpret that one easily. Like fruit points is going into a Sugino variable, that vegetable points going into a vegetable, and milk is going to milk, and rice is going to milk. This is an important one to give the output. After that one is the output. See that we recommended that season 24 FPMR, that is a fruit, vegetable, milk, and rice fuzzy that deployed in that one. I making inside and defining that fuzzy FPMR. See that please have some fruits. That means what they purchase. I given in a data set that is given. If I was telling sapota, apple, muscata, and grenades is there, you can purchase this one. And vegetable also some of the broccoli is there, and we can try the milk also. Cow milk and cow milk also you can purchase. And rice. It is taken from the high and low value. Low value means topest rated previous purchase behavior it will give. Yeah, highly we purchase milk is vegetable buy it with a high points means high rated point means we will give the lowest point, not buy it from anyone. We can give the milk like that one. But we want to give to the client means it is not necessary. It is not easily interpretable to the clients. So we making a deployment pod to suggest to the clients. So My friend Bobin will take over the deployment part. Thank you for doing, Bobin.
Thank you, Surya, for the introduction. Good evening, everyone. My name is Bobby. I am assigned to present from deployment to the future scope. Okay, let's go on with deployment. The deployment strategy that we adopted was team-led. Now, some of you may ask why we choose team-led. Because it is flexible and it doesn't require HTML, CSS, or Java. Like my friend explained in the programming coding part, it is all done in the backend. Let's see the image of the web deployment. Surya, let's go on to the next slide. Here you can see what we have created with simple, with Streamlit deployment. Next slide is the video of this deployment. Okay, as you can see, in the blank space, we are pasting the items bought by the customer, and it shows the recommended products based on the customer purchase. Okay, Surya, go on to the last part of the video. Here you can see the recommended products based on what customer has already bought. Next slide. Next, we have done another deployment, that is Heroku deployment. We have adopted this because we can use this anywhere using cloud. It is implemented with just 5 steps. In the step 1, we create GitHub repository, and step 2, we open Heroku and create an app. And step 3, we connect Heroku and GitHub. And how we connect Heroku and GitHub are using 3 files. Next slide. The first file is the requirement. We use all the library. The requirement file consists of all the libraries which we have used to write this code. Prod file is the standard syntax given by Heroku, and setup file is the code that we have written. After setup, it will give a live web application link which look like this. Yeah, select any item from any category. Here you can see Surya has selected fruits, and it will only recommend fruits because he have only selected fruits. But if he is selecting all those items from each category, then it will show a recommendation based on all the products which customer has selected. Okay, guys, this is all about Heroku deployment. We can get on with conclusion now. Okay, I can conclude this by giving a short story. Imagine you are in a cafe drinking coffee, and the owner of the cafe comes up to you and asks, "How is your coffee?" You cannot say yes or no, because you have to be specific, like very good, good, moderate, bad, is a worst coffee, something like that. So making those natural languages to accurate numeric number, we use fuzzy logic. This is a basic explanation for fuzzy logic. And this is what we have done through this project. Let's get on to the next slide, future scopes. Our project made customer recommendation around the time. That's a promise that we give from our project. We can improve the profit on both online and offline platforms. In this project, we can provide flexibility in choosing attributes, whether it is dependent or independent. That's all about this project. And let's have any questions. Okay, thank you for your patience and thank you all. I will good. I will wish a good luck for Team B.
Okay, I'll stop my share. Thank you all.
Good morning, everyone. Yeah.
Continue.
Good morning, everyone, and good evening, everyone. And thank you, Team A. And this was a marvelous presentation from Team A. Now it's Team B, and I will now, first of all, express my gratitude to all my mentors and all my team members for sharing their hard work and their guidance for completing this project. So it's now my team member Akshay will going to start this presentation. Over to you, Akshay.
Okay, thank you, Nikhil. Hello, everyone. Good evening. Thank you all for your presence. I'm Akshay. Me and my team are here for our project presentation on association rules and recommendation engine for high utility item sets. Our sincere thanks to Sharat sir for his support and guidance through our entire project, and also thanking Mr. Raju, our mentor, for his support for completing this project successfully. These are our team members: Sudhir, Vikas, Naman, Nikhil, Shyam, Nivedita, Akshay, Dev, Priya, and Sagar. We'll be covering various topics in our presentation. We'll explain project goals, project constraints, crisp ML methodology, technical stacks, project architecture, data preparation and data understanding, then model building and model deployment, and at last there will be conclusion with future scope. We have worked on market basket analysis in our project. It is a data mining technique used by retailers to increase sales by better understanding of customer purchasing patterns. Market basket analysis uncover associations between items. It works by looking for combinations of items that occur together frequently in transactions. In the very same way, we are using this technique in our project, creating if-then scenario. Like if item A is purchased, then item B is likely to be purchased, and further building association rules. Association rules have three parameters: support, confidence, and lift value. Support is the frequency of occurrence of an item set, and confidence value shows how frequently the consequent occurs among all the groups containing the antecedents. Antecedents are the if items and consequents are then items. And lift value of an association rule is a ratio of the confidence of the rule and the expected confidence of the rule. Expected confidence of the rule is defined as the product of the support values of the antecedents and the consequents divided by the support of the consequents. Association rules find all item sets that have support greater than the minimum support, and then using the large item sets to generate the desired rules that have confidence greater than the minimum confidence. Okay, next slide, Nikhil, please. Fuzzy logic teaches computer to make human-like decisions in an uncertain world. We are using fuzzy logic in our project to convert quantitative values of attributes to categorical ones, so as to eliminate any loss of information arising due to sharp partitions. A fuzzy set allows its members to have different degree of membership, called membership function, having interval 0 to 1. The values between 0 and 1 characterize fuzzy numbers, which are used for human reasoning. Like in Boolean logic, there are only two conditions, yes or no, on the scale of 1 or 0. But in fuzzy logic, there may be several conditions between 0 to 1. Scikit-fuzzy is a fuzzy logic Python package we are using in our project that works with NumPy arrays. And fuzzification is a process, operation to convert crisp numbers into fuzzy numbers. Crisp value is either 0 or 1, but fuzzy values are between 0 and 1, including both 0 and 1. We are using fuzzification process as it allows the rules to be applied in a very simple manner to express a complex system. And defuzzification is the inverse process of fuzzification, where the mapping is done to convert the fuzzy results into the crisp results. Okay, next slide. From this slide onwards, my friend, my team member Shyam will take over. Thank you.
Thank you, Akshay. Good evening, all. Myself, Shyam Sundar. And the main objective of this project is to provide the association rules and recommendation engine to the retailers to increase their business growth and maximize the customer satisfaction and easy of customer selection. And obviously, they are increasing their profits after getting the recommendation engine and association rules. And the constraints of this project is the more data will require the more storage, and more data will take a long time to process, and highly configuration hardware is required to process the huge data. And we felt these are the constraints of this project. And next, crisp ML methodology. And this is the whole process, means end-to-end process, which we are performing any project and data science. And the very first step is understanding the business. And in this step, we are understanding what is the problem occurred in the business and data engineering. So uh, uh, we have to go through the data engineer for data preparation. And in this stage, we have to remove the null values and duplicate values presented in the data, and we can convert the raw data into a useful manner, which we are performing on model building. And the very next step is model building. In that model building, we have applied some techniques and some algorithms to gain the output. And testing is next step after the model building. And in the testing, we are rechecking the whole process which we are done in the model building, and it will be fine or not by we can verify in the testing and deployment part. And in the deployment part, we can gain the output in the form of a useful manner and monitoring and maintenance. The output will be hand over to the client for maintenance. And next slide, please. Here the list of technical stacks which we are used for this project, and we used Python version 3 and NumPy. It is a numerical Python. It is useful for perform the highly complicated mathematical operations, and Pandas, which we are used for read the data set. And by using the Pandas and NumPy, we can find out the null values and duplicate values. And Matplotlib. Matplotlib is for visualization effects, and by using the visualization effects, we can understand the data in a clear manner, and we can understand easily by the graphical representation also. And Google Colab is for a general ID used for coding purpose, and Jupyter, Spider, Flask for deploymenting the whole code. And skfuzzy is one of the main algorithm which we are used to generate the recommendation engine and provide the association rules. And skfuzzy converts uh, the output will be in the form of the crisp value. And we can apply this skfuzzy to the crisp value and we gain output. And my friends will be explain upcoming slides the whole process what we have done. And next slide will be continued by my friend Dev Kumar.
Thank you, Shyam. And now here we can see the complete project architecture, starting with the business understanding. My friend Shyam already briefed you about the objective and the constraint of the business. Here we collect the raw data from the defined sources and upload it in our database. As this is the raw data, we need to pre-process it and clean by removing unnecessary and the null values. Here we use the matplotlib for the visualization purpose. Now we have a refined data. So in the very next process, we prepare a model to achieve a business goal. Here we use some algorithm and the rules like a prior association rule and the fuzzy algorithm. After preparing a successful model, we need to deploy it over a web. And for this, we use a Flash to give it a user interface. And obviously, after completing a complete project, we need to monitor it for any maintenance. So Priya will continue from here.
Thank you, Dev. Priya here. Now I'm going to explain the rest of the 3 slides, like data preparation. In this data preparation, before we use the data for our project, we have to do some cleansing. Like we need to organize our data. This is most time consuming part also, and how we are going to prepare our data using removing some null values, some duplicate values, and removing unnecessary columns from our data sets, like some merging columns. Everything will be included in this part. The next one is data understanding. This is a secondary data set, and which contains all the transaction occurring between December 2010 and December 2011 for UK based and registered non-UK non-store online retail. The total observation 5,41,000. What are the columns here? Invoice number, stock code, description, quantity, invoice date, unit price, customer ID, country. All the columns in this data set. And this is also time series data sets, like date, time, and sequence in which we arrange the data is important. The next one is feature description. Here, invoice number. System will generate this ID during each transaction. This is unique ID, and this is a nominal data. And stock code. This is a code for each product, and also unique ID. And this is also nominal data. Description. It contains list of products names, and this is a nominal data. And the quantity. The quantities of each product per transaction. So this is also numeric type. Invoice date. This gives informations, date and time when each transaction was generated. So next is unit price, price of each product per unit. Then customer ID. This is also unique ID for each customer. Then country, country of purchase. This is also nominal data. So we are not going to use all these columns for our project. Like we are going to use only invoice number and description. The rest of stock code and quantity, invoice date, unit price, and customer ID and country. We are going to remove this. That's all. Thank you. I hand over to Nikhil.
Thank you. And now we are going to move a most important part of the presentation, that is model building. So what is basically a model building? It's the core part of a programming, and we can say the project where we're going to execute whatever data we have given, whatever the data we execute, and whatever the main goal of a project will be executed with the help of model building. So what is basically we are doing over here, we are using a prior association rule and SK fuzzy logic. So in a prior association rule, we are combining and getting the result, and that is in a prior one, it's a frequency of item set that is occurring together, and association rule is subset of item sets that are occurring with together with like statistics like left confidence and left confidence and etc. And SK fuzzy logic, we had used SK fuzzy logic to show that how we means SK fuzzy logic is used so that we can show that how it is like a controller who is going to regulate that what is the basic probability of selling the products together. So in our this complete project, we are trying to build a prior association rule for recommendation, and after recommendation we are controlling it with the help of SK fuzzy controller, which is set up on an association rule a prior, so that we can get a particular value with accuracy, which is used in a form of a continuous format. That is what we are using a SK fuzzy controller. So model description, we are creating an item set using a prior algorithm, creating rule using association rule to find the lift and confidence, using SK fuzzy to perform fuzzification, defuzzification, enter the lift and confidence value to predict the probability. So what is basically we are doing is that our whole model is divided into two parts. One is where we are using a prior algorithm, and second we are using fuzzification and building a controller. By using step one, we are using a data set and a prior algorithm, output the association rule, and output will be given in a form of crisp value. When we get this crisp value, we fuzzify it, so we can convert these discrete value into continuous format, and these fuzzy variable will be used in a form of fuzzy logic rule. And this fuzzy logic rule will be fuzzy variable, and this fuzzy variable again defuzzifies, so that defuzzification process is involved, where we again convert this continuous value into discrete output, so that we can get this continuous format can be converted into a user understandable form in a form of a crisp output. Here we have a code. In code, we have used important libraries that we have used are Pandas, Matplotlib, collection, ML extend frequent pattern with a prior, and again with same library with association rule, then NumPy, SK fuzzy import control. So SK fuzzy and SK fuzzy control is used to build a controller, and SK fuzzy is used to build means membership functions and all. So basically what we are doing is that in first line we are reading the data, and then we are getting its values, its information, then we are dropping like data like country, invoice, stock code, quantity, and unit price, and customer ID. First we are drop, and then after that we are building again in a data frame grouping by group in data 4, when we again taken another data sets, and in that data frame what we are going to do it, we are going invoice and description, we are applying a list function to it to reset index name and transaction. In frequent item sets, we are taking the variable name frequent at the side, where we're using a prior algorithm with minimum support of 75% and maximum length in 4, and using a column is true. In frequent items sort values, we are using support incident false and in place equals to true, and we are using rules association rule with the frequent item set, matrix is left, and minimum threshold is 1. And the main part is that we are using filter for antecedent, consequent, lift, and confidence, because when this rule, when what we are doing is that we are getting the recommendation, we are achieving a recommendation with the help of association rule, and once we get all the recommendation of the items on that data frame, that is a frozen set, that on that data sets we are going to add a filter, and we are getting the value of antecedent, consequent, lift, and confidence, which is we again converted into data frame format in a form of M. Now the data which we get means after applying the a prior algorithm and the recommendation item with value of antecedent, consequent, lift, and confidence, this is a data of the value item, those who are occurring together. And now on a basis of lift and confidence, we are going to use a SK fuzzy logic on this lift and confidence values of these items that are occurring together, that is 2,99,212 rows and 4 columns. These many items we are getting together with lift and confidence, consequent, antecedent. And now we come on the main part of the presentation, that is fuzzification. So what we are using is that we are first of all, if we talk about fuzzification, it have 3 important input important members, that is antecedent, that is taken as an input, consequent, which is taken as an output, and a membership function, which is used to create a like poor, average, good. These are the membership function that can be further be classified into more complex and more extended format. So how we are going to do it, that we have taken a 3 variable named lift, confidence, and point. So according to a lift and confidence, by watching the elements lift and confidence, we are going to assign it's a some point, and according to those points will we find the probability of these products occurring together. So we have NP arranged from 0 to 15 with a difference of 5 elements, and confidence we have like 0 to 1 with the difference of 0.1, and points we are arranging from 0 to 11 with difference of 1. Lift auto MF function. What auto MF function is used in like you can see there are 3 segregated graphs. It is poor, average, and good. Like this, when we use auto MF, that is automatically generated membership function, we can increase it 3, 4, and 5 variables. That is, either we can describe our continuous format like poor, average, good, very good, and excellent, or we can describe poor, average, fair, good, very good, and excellent. Like this, we are generating an automatic function, and these automatic functions are used with the help of a controller library. And this is the inbuilt function that comes when you use skfuzzy library, and you can automatically call it. But to make the process very easy and very understandable format, we keep it at lower level only for a poor, average, and good, so that we can find the quality of the product that we get. We can refine it, and it will be not too complex that it create a problem of overfitting. And that's why we are using these poor, average, and good to make it make our prediction in a proper format. So now we are using a custom membership, and now as you can see, it is in a triangle format. So why it is in triangle format? Because we're using a trimf function. What is trimf? That is triangular membership function, trimf. We can also use a trapmf, that is of a trapezoid membership function. In trimf, we have only used to give a 3 value, that is 004 or 003, means we only give a 3 inputs over there. But in trapmf, we have to use 4 values accordingly. And that format, if right now you can see that it's a triangle format, but if you see this value, it's have this it's have this this format. It is in a form of is a plane over here. So in it will, if we use trapmf, it will be in the form of trapezium format. And in trimf, it is in a form of a triangular format. So in here we generate custom membership function, and for interactively and with familiar points. So we use a point universe with 004. It will be in a form of 0 to 0 range, and that is in a form of 0, 1, 2, 3, 4. In 2, 5, 8, it will be between 2 and 5 with eight different types of 8 values that will be given in a medium, and high will be between 6 to 10, and in 6 to 10 there will be 10 different values that will be in a form of points like 0.1, 0.2, 6.21, 6.2, 6.3 up to 10, unless it reach to 10. Then we shows like a lift view, point view, and confidence view. These are 3 different types of graph which are generating from here. Then we generate a rule, right? So if 2 products occur together, one product have a probability of getting together, like if we take example of beer and diaper, it will have a probability of very good of selling together, then it will come in a form of a good, and the point we are going to allot it has a very high probability of selling the item. On other hand, if I take if I have a razor blade and selling it with a with a microwave, it will have very poor confidence and lift ratio. So that will become in a poor, and the point we are going to allot it will be the low. So like this, we developed the 3 rules. Rule 1 will we have a poor, and when lift will be poor and confidence will be poor, then the point we are going to allot it will be low. When lift is average and confidence will be also average, then the point we are going to allot is medium. And when a lift is good and a confidence good, when the point we are allowing will be high. So system controls, then we use system control CTRL. This is an inbuilt system that will use rule 1, rule 2, and rule 3 to execute the code. Means according to this, whatever feedback we give it to it, this will then predict it by combining these 3 graphs together, and will predict what will be the probability, which will with using skfuzzy, not simple, we're using fuzzy logic. What will the probability of selling these 2 elements together, like jumbo bag pink or jumbo bag red, and what are the probability of these are the items which we have in our item list. So that's why I'm talking about jumbo bag 1 and jumbo bag red. It's not random, this is from our data sets, that's why I'm adding it. So like that, if these two items, what are the probability of occurring these two elements together, and that probability will be calculated not like a probability format, but in the form of a SK fuzzy rule. So for example, I have put in lift of 7.7 and confidence. So it is showing that means it is giving the output that we have a probability of 50% of getting these elements together. Like means when we going to show you a deployment video of this, so you can easily come to know that how we are getting it, because there we have already explained very well. Means in deployment part you get quite a good understanding is how these are working together, because their code is running. So like this in system lift, when we add 7.4 and confidence of 0.6, so probability that it will give is that it is coming between 4 to 6, like probability is 50%, which is coming in between 4 to 6, that is 50% probability. And the probability of selling this item together is very high, and it is in range of very medium. Means it's a medium, this orange curve you can see, it's a medium, and it is in between. This means it have a range from 2 to 8, and it have a high probability, it is a medium probability which is come in a medium range. You can see it's the orange color medium over here, and it is a 50% probability, which is a good probability of selling to the element. Like example, bag and copies, stationer bag and copy or notebook, what is selling of this probability together, it is saying that is 50% is a person coming to buy the bag, it will definitely going to purchase a book also. So that's the book or notebook. So that is the probability, and we are saying it's a 50% probability depending on the fuzzy logic that we have built. And this fuzzy logic, and you might be thinking that how these two elements are coming together. For that we have using a prior algorithm, so that we after see how this process is working, we use a prior one, then we have used a prior one, and after the a prior one we build a recommendation system through it, and we get certain values out of it. And when we get this certain value, on that we apply the controller which is built from the fuzzy. So fuzzy is used to build a controller which is going to regulate what is the probability of it, and the how we are going to get these frequency of item sets occurring together, that is we have developed with the help of a prior one. So deployment part will be handled by Naman. Over to you, Naman, and thank you for listening me.
Thank you, Nikhil. Yeah, good evening, everyone. This is Naman. I will take you through the deployment part. So basically, deployment means that our model is ready to use. So for in deployment, what we did is there is a server where we put our model, and using front end, we request that model. And on the basis of that request, we get some response, and we display that output on our screen. So for deployment, we have used Flask. Flask is a framework in Python which is used to build web application. It is easy to use. We can also use Streamlit also, but we prefer Flask as it was easy for us. Now let me take you to the code part. Okay, so before coming to the code part, what we did was we saved our system, like pre-trained system, in the form of a pickle. We use pickle to save the system. Now what we are doing in this Flask is, first we are importing all the packages, then we are initializing the Flask object. It means that we are creating here Flask. Then we are importing our system, which is saved in the form of a pickle file. Then we have this @app.root \, which tells the Flask app that this is the first thing which it has to load. In this, we have a home function which renders an HTML template. In HTML template, what we have is a form which consists of two text box and one button. So for those two text boxes are used to take the input from user, the lift and the confidence value. And when you submit it, you will redirect to the new page, that is the predict. We have not used a different HTML for this predict. We are printing on the same page. So what we are doing is we are taking those two input and giving this into a system. Our system will compute this lift and confidence value on basis of these values, it will generate the probability that what is the probability of buying the two items set together. Let me take you to the deployment video, Nikhil. Yeah, so this is the first page, which we will see, where we enter the lift and confidence value. And when we submit, click on the predict button, we get the probability. So from where we are getting this lift and confidence value, let me show you. So here we are getting the lift and confidence value. From here we are putting this lift in the lift text box and confidence in the confidence text box. We click on the predict button, we will get the probability. So this is how our recommendation system works. So now my friend Rajan will conclude on this project.
Hi all, Ranjan this side. I'll be covering the conclusion and future scope part. First of all, conclusion. Why we use the fuzzy association rules rather than the crisp association rules? Because of the certain reasons. First, the crisp association rules used to convert the numeric attributes into binary ones. For example, income is equals to 100K and above. It will tend to increase the loss of the information due to the sharp ranges. Whereas fuzzy association rules uses fuzzy logic to convert the numeric attributes to fuzzy attributes, like income is high, which will tend to decrease the risk of loss of the information due to these high ranges. Therefore, using the fuzzy sets over here will be the best practice to be used in this data mining. Second part will be the future scope. According to our group, fuzzy logic will be having the great future scope in the future. It will be divided into two parts. Why we are saying this? Firstly, results have influentially greatly used by manual membership functions. So it is needed to automate the threshold values for better fuzzy rule creation. We are just using the one data set over here, and all the group members are using the one data set, and we have done all the things, all the terminologies manually. And in the future aspects, we'll be combining the multiple data sets, and we have to automate all the things to increase their productivity, to increase the probability of the result, to decrease the manpower, to increase the outcome according to the client's demand. Therefore, will be using the fuzzy algorithm in future for these reasons. There is a need of automation in the model, which can be done in the future. Thank you. Now group C will share their presentation for this topic.
Hello everyone, my name is Shalini. I and my team are here to present a project on association rule and recommendation engine for high utility item set. So before I proceed further, I would like to thank the director of InnoDataTix, Sharath Manikonda sir, and I also like to thank our project mentor, Imran Ali and Rajuji. Yeah, so I would like to thanks to our project mentor, Mr. Imran Ali and Rajuji. Now I would like to introduce my team members, Vibhuti, Ansh, Vinit, Padmanabha, Shalini, Rohan, Nishan Kapoor, Prem Sai, Rajkumar, Rutuja, Satyanarayana, Vasudha, and Sharon. Divya Polana, Ankita, and Harshit Goel. Now, I would like to take you to some basic introduction to our project. So that our project is mainly focused on recommending a product to a customer and searching a correlation between the customer. Recommending using a fuzzy logic in a retail domain is going to give a rapid accuracy on a large data set. Manually recommending products and high utility products to the customer is a challenging, or we can say it as it's a difficult task. The goal of our project is to recommend a high utility item set. So coming to the project objective of this high utility item set is to maximize the recommendation to the customer and also at the same time maximize the profit. On the other side, we have a constraint also that we need to minimize the wrong recommendation to a customer. Let's move to the next slide, that is a CRISP MLQ methodology, which have 6 stages. So the first stage is a business and the data understanding. So our business understanding, or we can say it as an objective of the project, is to recommend a high utility item set to a customer and the data set that have a 5,41,909 rows and 8 columns. Now the second stage comes, that is a data engineering. Here we prepare, or we can say it as a process our data for model building. We perform such steps like a data selection, data cleaning, feature engineering, and data standardization. And some more steps also we perform in data engineering. The third stage in the CRISP MLQ methodology is a model building. So here we select a model that is based on or suitable to our project. So here we have built our project using a fuzzy algorithm. The fourth stage of a CRISP MLQ is model testing and model evaluation. In this stage, we check the performance of the model on the test data and evaluate its accuracy. The fifth stage is the model deployment. This denotes the process of ML integration into existing software. In case our model is not able to give an expected output, so again we move to the first stage and perform the necessary changes in the data. If our model is giving the expected output, then we'll move to the last stage that we call it as a maintenance and monitoring. So this last stage we do when the model will deployed at the client side. So these are all the 6 stages of the CRISP MLQ. Now let's move to the next slide, that is a technical stacks. So we have used here Python programming to design or to code our project. So to perform a coding, as I said, we have used a Python. So Python is an open source and easy to code language. And here we have used a Spider as an IDE to code our program. Next, we have used some of the Python libraries like NumPy, Pandas, Matplotlib, FuzzyWuzzy, and for visualization, we have used a Matplotlib. And for the deployment, we have used a framework called as Streamlit to build our to deploy our application. So that's all from my side. Thank you. And now Vibhuti will continue further to explain more about our project.
Yeah, Shalini, thank you. Good evening, everyone. Myself, Vibhuti. I'm going to continue with system requirement and environment part. So for the project, we need some specific system requirements like 8 GB memory, Windows 10 OS, and we use Python 3.8 version. We use IDE, Spider, and Google Colab. For data visualization, we use Matplotlib library and NumPy for calculation And we use Pandas for data manipulation. We use fuzzy wuzzy library for item string matching. Now we are moving to the next slide. Next slide, please. Project architecture, data pipeline. We know the what is project objective. It is a recommendation engine for high utility item set. So in data understanding, we need to understand for what purpose we need to collect the data. So we start collecting the data. We collect 2 months transaction data. This is primary data. We collect data from online research. Then data is stored in database, which is MySQL database. We extract the data from database using MySQL.connector, and then we did data pre-processing, mean we perform EDA on data. And for visualization, we use Matplotlib and Seaborn library. After this, we did modeling through the a priori algorithm by fuzzy logic and got the high utility item. After getting the result, we did the model deployment part using Streamlit. So with these things, client can able to monitor the things easily. Now we are moving to the next slide. Data collection. So we have the primary data, which has 5,41,000 and 8 columns. Data is from UK based company. Now we are moving to the next slide. We have 8 attributes, or we can say 8 columns. Invoice number, which has 6-digit unique number. Stock code, which is 5-digit unique code. Description is product name. Quantity is each product per transaction. Invoice date is date time, which is numeric. The date time is when each transaction was generated. Unit price. Unit price is product price per unit, which is numeric. Customer ID, 5-digit unique number assigned to each customer. Country is where each customer resides. Now we are moving to the next slide. Data meaning. We have some null values in description column, so we dropped them. Extra spaces from description column are also removed. We removed the invoice number, which contains the value C, means item bought on credit, that can affect the model accuracy. So this is all about from my side. Some next slides onwards, Harshit will continue.
Yeah, thank you so much, Vibhuti. So, guys, I will be taking over through EDA, exploratory data analysis, in which we have taken like a good time to analyze like what kind of data we are getting and what are the insights we are getting from the data. So, in the first slide, we can see we are getting the top 5 frequently items sold. The first one is white hanging t-shirt, tea light holder, followed by Regency cake stand, 3 tire, followed by jumbo bag, red, followed by party bunting, and assorted color bird ornament. So these are the 5 frequent item sold which we are getting from our data set. Can we move to the next slide, please? So now we are seeing from which country we are getting the maximum number of, as we can see from United Kingdom, we are getting the maximum transactions, which are 3,54,345, followed by Germany, around 285. So these are the top 5 countries by the transaction from where the customer has transactions, and in which we can see UK has made the highest number of orders. And we can see this in the bar chart also. Can we move to the next slide? Yeah. So in this slide, we can see the monthly number of transactions. Yes. So in this slide, we can see the monthly number of transactions. So as we can clearly see from the year 2011, we can see the maximum number of transactions, which is in the month of November, which is around 64,545, followed by October around 49,000, followed by September around 42,000, followed by May and August. And in this also, we can clearly see that in the month of November, we are getting the maximum number of transactions, and December is around 17,000. In 2011 has the lowest number of transactions. So in this, we can see transactions by week on the weekly basis. So we can see on Thursdays, we have made the maximum number of transactions, approximately 80,000, followed by Wednesday, Tuesday, Monday, Sunday, and Friday. And we can see in this graph that no transactions has been made on Saturdays. Now we can see the hourly transactions. We can see like the maximum number of transactions have been made between 12 p.m. to 3 p.m. only, and the maximum transactions have been made at the time of 12 p.m. So now Ansh will take over from here.
Thank you, Harshit. Hi, myself Ansh Vadera. So let's now see the model building part. So for the model building, first let's understand what is fuzzy logic and fuzzy algorithm, because it will be used in our coding part. So let's start with crisp sets. What is crisp sets? Crisp sets are the normal sets what we use in mathematics, and in that the elements are present in that set or not present in that set. There are only two possibilities: yes or no, like 0 and 1 in our computers. So, but the fuzzy sets are different from the normal sets. In these sets, the element can be partially present, or it can even not present and can be fully present. So in this, there's a function used, membership function. That function, the number is between 0 and 1, and that shows the belongingness of the element with the set. Like if it's 0.4, so the element is only 0.4, like 40% present in that set and 60% in some other set, or it's divided. So this is not only the black and white, it also gives us the shades of gray. Next slide, please. So this is an example for a fuzzy logic to understand more clearly. Like in Boolean logic in your computers, or we can say in normal set, like is Nick honest? We can is only 1 or 0, like true or false. He's honest or he's not honest. But in a real world examples and in real world, this is not the case. People are not perfectly honest and people are not very wholly dishonest. So in fuzzy logic, what we use, like some are extremely honest, the membership function will be 1. Very honest, it's 0.85. Sometimes honest, it's 0.35. Like say this, in this, it's below 0.5. And extremely dishonest, this is the extreme case, which is 0. So in this, this is the difference between the Boolean logic and a fuzzy logic. Next slide, please. Now we are through with the concepts of fuzzy logic. Now let's see how our model works. So we have a product list, unique product list, and what we do, there's a customer who bought a product. So what we'll do, we matches that product with our unique set of products, and what our function will do, it will give a score between 0 and 100, like in fuzzy logic, fuzzy set. It is not only 0 and not only 100, but between 0 and 100. So, where 0 means no match and 100 means exact match. So what we will do, as it will give the score, there's also a thing cutoff value. We will specify a cutoff value like 50. It will only take out the products which have the score greater than 50. And then after taking out all the products, we will arrange that products with respect to the high utility products. Like the most sold product will be shown first and will be in first in a list, while the least sold in those products will be in the last. And those products will be recommended to the customer with respect to the high utility item sets. Next slide, please. So this was the concept. Now let's see the coding part. How this is the main function. After pre-processing, we apply this function where in scores, this list will contain all the scores between 0 to 100 with the products we are matching. This while loop, what it will do, it will append the scores which is more greater than 50, what we have specified in the cutoff. We have specified 50 as a cutoff, which is default. After that, in this loop, we'll adding that recommended list and removing the duplicates. If we have some duplicates items, like we can't show or recommend a product twice or thrice to a customer. So we are removing all the duplicates if had any. And after, in the last loop, we are sorting the values in terms of high utility items with like the most sold product will be the first and so on. So this is the whole coding part. Next slide, please. Now comes the deployment part. The deployment part is, this is our fuzzy recommender system where we will specify a name, like product name, like we have specified Christmas. Then after recommending it, we will get these products which are sorted and also have the score greater than 50. We can also change the cutoff value, how rigorous we want our recommendation. We can change our cutoff value. And this is the deployment, what like as we type our product name, that time only that function runs in background. And this is done, we have done with Streamlit. This is the deployed part. Now, Prakhar will take to the conclusion part. Thank you.
That was very good explanation, Ansh. Good evening, everybody. This is Prakhar. Right now, I'm going to explain about the conclusion, development, and future scope of our project. So by this project, we're going to showcase the customer satisfaction product by improving the business profits. Also, by tracking previous customer purchases, it is easy for us to find the high utility items. By this, we can easily meet the demand supply. And coming to development part, there is the other ways to develop the development is by using deep learning techniques such as RNN, by instead of going for fuzzy logic. And as we all know that when we use machine learning or artificial intelligence, the machine takes it takes time to learn itself. So the model can be improved automatically as the time goes. Next slide, please. So future scope, the main objective of our project is to recommend the best product to the customer. Right now in the data set, we have taken the gift data set, but we can also apply this to any of the categories that is there with the business. So this can be applied to any of the online retail data store. So in our project, we have used fuzzy fuzzy, which is a fuzzy algorithm parameter. By changing the tuning or by tuning this fuzzy fuzzy parameter, we are able to monitor the product recommendations. So by this, we are able to achieve what kind of products we wanted to show to the customer, and and what are the products we are not going to show to the customer. We can able to monitor here by using fuzzy fuzzy. And as the model runs all the time, it is easy to meet the customer recommendations around the clock, as this algorithm uses the best and efficient way to recommend the products. So it definitely improves the business performance. So it leads to the more sales of the company. Next slide, please. So if you have any questions, we are here to answer you. You can type this in the chat board, or if you are following this in the YouTube, you can write it in the comments below. We are here to take your questions. So you have any questions, you can write, you can type it in the chat board. Okay, thank you everyone. Thank you InnoDataTechs, our mentors and coordinators. Also very much thanks to our teammates who has given their vital part by making our project very successful. Or to our project mentors, thank you. Thanks a lot and have a great day.